going to do some more AP review. This is 2010 AB free response number 5. This is AB only. It was not on the BC exam. So this is one of those problems where you're given a graph of a derivative. So this is the graph of g prime. So the function g is defined and differentiable on the closed interval from -7 to 5 and satisfies g of 0 equals 5. The graph of y equals f prime of x, the derivative of, g prime of x, my bad, the derivative of g, consists of a semicircle, right, that's a semicircle, and 3 line segments, as shown in this figure. Okay, part A, find g of 3 and g of -2. So this is a first fundamental theorem of calculus question, right? So we've seen the first fundamental theorem of calculus before. The first fundamental theorem of calculus, if we just squeeze this maybe up here, I think you can see it, first fundamental theorem of calculus is that if you integrate some f prime of x with respect to x from a to b, right, you'd get f of b minus f of a. So we've seen this problem a bunch before, right? And when we see this first fundamental theorem of calculus, what's going to happen is we're going to be given an f prime or a g prime or whatever prime, but I'm using f prime as an example here. We're going to be given some derivative that we are able to integrate in one of two ways. Either we're able to integrate it on a calculator, like you could be given some f prime that's really ugly and complicated, but it's a calculator section, or you're able to integrate it using geometry because you're handed an f prime that is a bunch of very convenient geometric shapes, and that's the point we're at right now. These are convenient geometric shapes. I've got area that I can find easily because of semicircles. I've got area of triangles and area of like all sorts of things like triangles, trapezoids, rectangles, semicircles. That's this kind of problem. And then you're going to be given either f of b or f of a and asked to find the other one. So that's the point we're at here. So we were given, right, we were conveniently given a g prime of x with easy geometric shapes, right, easy geometric shapes. And we were also given g of 0 equals 5, right? We're then asked to find two things, g of 3 and g of -2. So let's start with g of 3. So g of 3, right, if I want to find g of 3, here's the trick. And I'm just going to give myself actually an arrow here to show you that we're not talking equal yet. If I integrate g prime of x, right, with respect to x from 0 to 3, that, based on this first fundamental theorem of calculus right up here, that's going to give me g of 3 minus g of 0. Well, this is something I can find using geometric area, right, like all these nice shapes. This is something that was given to me, right, and I want g of 3. That's what these first fundamental theorem of calculus questions are about. So let's go ahead and find those values. So basically, if I want g of 3, right, g of 3 is going to be what happens if I add the g of 0 over. So I'm going to add it to the other side, like I'm going to add g of 0 over and get 5, which is g of 0, plus whatever this area is that I'm totally going to be able to find, right? That's what I need. Now, in terms of work, the way I usually do this, and you don't have to do it the way I do it, certainly. There are any number of reasons that the way I do things is not the best, including that I just like chucked a marker at you. So the area from 0 to 3 is going to be a quarter circle plus this chunk of triangle, right? So for me personally, when I do this, I tend to write this as a 5 plus, and then I just kind of go like full on like hieroglyphs instead of math, and I'm like, hey, quarter circle plus triangle, so that in my brain I'm like, that's what I need to find. So this is a 5 plus 1/4 pi r squared. Well, the radius of this semicircle is 2, so that'll be a 4, right, 2 squared, plus 1/2. The base of this triangle is 1 and the height is 3. So 1/2 the base times the height would be a 3 times the half. So I'm pretty sure that I get that g of 3 is a 5 plus a pi plus a 3/2, which is not technically a wrong answer, but there's a solid chance that they want you to at least bother to put the 5 and the 3/2 together, right? So this is 10 halves. So the best answer you're probably going to see is a pi plus 13 halves or a pi plus 6.5 or any of those. Okay, so that's the first part of A. Now we're going to do this same set of scales again, but we're going to do it for g of -2, and it just means using a different chunk of the graph, but the same scale set. So let's do this again. Right, let's go ahead and do the second one, which is to find g of -2. Now you have a few options for g of -2. The trick with g of -2 is that it's in the reverse order, so there's a couple ways you can deal with this. You can either integrate backwards from 0 to -2, which is fine, but keep in mind that if you integrate with reverse bounds, then you have to put a negative in front of things. Or you can say, hey, you know what, I feel the most comfortable integrating in normal order from -2 to 0 of g prime of x dx. And if you do feel more comfortable with that, that's fine. if you do that, what's going to happen is you're going to get g of 0, which is the thing you know, minus g of negative 2, which is the thing you don't. So when you go to solve for this thing, right, this is the thing you want, you're going to add this guy over and subtract the integral. So what's going to happen is your g of negative 2 is going to end up, he got added to this side, and I subtract the integral over. So I get g of 0 minus the integral from negative 2 to 0 of g prime of x dx. So what's going to happen is I get a 5, that's what g of 0 was, right? Minus, and then in parentheses, I'm going to say, hey, what's the integral from negative 2 to 0? Oh, I don't even need the parentheses. It's minus whatever this quarter circle is. And conveniently, I already found the other quarter circle in the last part. So my g of negative 2 should be a 5 minus a pi, because I know that it's still that same quarter circle. It's just the other chunk of quarter circle. So that's my g of negative 2. Okay, so that's the first fundamental theorem of calculus. Let's go on to part B. On part B, we are asked, so we're said, find the x-coordinate of each point of inflection of the graph of g on the open interval from negative 7 to 5. Explain your reasoning. Okay, so for me personally, and anybody that's had me in class knows this, I'm a big fan of the math flowchart. So, so what I tend to write is I say, okay, cool, they want the x-coordinate of a point of inflection of g, right? So of g. So I say, okay, if that's what they're asking, right, that's the actual question I was asked to find. I have to think, what's the definition of a point of inflection? The definition of a point of inflection is a place where the second derivative of this function is 0 or does not exist and changes sign. So I say, cool, this is where g double prime equals 0 or does not exist, and this is the important part, changes sign, right? So that's, I need where g double prime is 0 or does not exist. Now, before I go much farther, I'm going to point out that they told me that this graph, so we'll talk about the does not exist in a sec. So g double prime is 0, or that says or, it looks like of, or does not exist, and changes sign. Okay, so now here's the problem. This is the definition, right? So I take what they ask, right, and I change that to sort of the mathy definition. Great, but then here's the leap. The mental leap is, how do I see that with my eyeballs? I'm not given g, and I'm not given g prime, or g double prime. What I'm given is g prime. So I say to myself, oh, prime means, so derivative means slope. So g double prime is the slope of g prime equals 0 or does not exist. That's what we're looking for, is where the slope of g double prime is 0 or does not exist, and then changes sign, right? So, and changes sign. We're going to need it to change sign. But again, the connection you have to make, right, the big mental leap, is that you're looking at the slope of the graph you're given. So we're going to use blue and green probably, because I already used red for something. Okay, so, well, let's see how successfully I can erase the red first. All right, there we go, close enough. Okay, so, so this is my terrible version of my graph. Okay, so let's start by finding the places where g prime is 0, right? G prime is 0. Sorry, the slope of g prime is 0, my bad. So the slope of g prime is 0, right? The slope of this thing is 0, where this graph, the given graph, has a horizontal tangent. So that's one spot, and that's the only spot. So seems to me that g prime, so g double prime equals 0. The slope of g prime equals 0 only at one spot, at x equals 0, right? There are some other spots where g double prime doesn't exist, right? G double prime doesn't exist anywhere that I could not derive the g prime graph. Well, I can't derive at pointy things. So here, here, and here, g double prime does not exist. So that's at x equals negative 2, 2, and 3. Right? So those are essentially the points I need to consider as contenders for points of inflection. So these are the contenders, right? So these are the contenders for points of inflection. So these are possible points of inflection. But what makes them a point of inflection is if at those points the slope changes sign, right? Like this, the slope of this given graph, the slope of this graph would be my g double prime, changes sign. So what I want you to notice is that this is a positive slope. And this is still a positive slope. But then, suddenly, negative slope, right? And then positive slope, and then negative slope again. So if I'm looking for where G double prime changes sign, my answer would be that it happens here, that's a point of inflection, right? And here, that's a point of inflection, and here, that's a point of inflection. So my answer is that there are points of inflection at x equals -2, x equals 0, and x equals, oh, sorry, not -2. Take it back. Brain died a little. There are points of inflection at x equals 0. Sorry, I saw the giant red circle and didn't realize that those were from earlier circles. So at 0, 2, and 3. So at 0, 2, and 3. Now, why? Because you're asked to justify your answer or explain your reasoning. My reason is at x equals 0, you could either say the slope of, so at x equals 0, you could either say the slope of G prime changes from positive to negative, or you could say G prime changes from increasing to decreasing. So I'm going to say the slope of G prime changes from positive to negative, right? For 2, and I'm also going to give the same explanation for the third one, right? Because the third one at 3 is positive to negative. So again, slope of G prime changes from positive to negative, right? And in the middle one, I'm going to say the slope of G prime does the opposite thing, right? It changes from negative to positive, right? And you could write out the entire word. I'm just kind of a lazy human. So, again, another way you'll see this written by the AP sometimes is instead of saying the slope of G prime changes from positive to negative, they might say that G prime changes from increasing to decreasing, or G prime changes from decreasing to increasing, and from increasing to decreasing. So again, that's the points of inflection. But when you see a problem like this, the first thing you should write down is what they ask you. Then you should try to write down what the mathematical definition of the thing they asked you is, which has nothing to do with application, is just a matter of what's the definition of a point of inflection. Write down the definition, and then the mental leap is to take whatever definition you see and link that to what you can see with your eyeballs. That's the mental leap, and then you can start to answer the question. All right. Okay, cool. Let's do part D. I kind of messed up this whole graph, so I'm hoping we don't need it too much. All right. The function h of x is defined by h of x equals g of x minus 1/2 x squared. Find the x coordinate of each critical point of h, and classify each critical point as a relative max, min, or neither. Okay, cool, and then explain our reasoning. I am probably going to need that graph again, so I'm going to do my best to not completely and totally butcher it when I redraw it, because I think I'm going to need it. Okay, so don't be too critical of my drawing skills, because they're not great. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. I think it only went up to 3, and I think it went down here. Okay, so I had a semicircle. I had the point at 3, 3. I had this guy, it's something like that, and this guy. Close enough. Okay, so this is my G prime of x. Okay. All right, so here's what we know. We're given what h of x is. So this is part C, not D, my bad. So part C. We are given that h of x is g of x minus 1/2 x squared. We are asked for the critical points of h of x, and we are asked to classify them as max, min, or neither, right? So that's what we're asked to do. So the first thing I need to do, and it goes along with that flowchart idea, is I need to know what a critical point is, right? So I need to know that a critical point is when h prime is 0 or does not exist, right? So in my brain, I think, oh, okay, a critical point is h prime equals 0 or h prime does not exist, right? Those are the two things I need. H prime equals 0 or h prime does not exist. So before I do anything else, I realize that this is about h prime, so I very much need to find h prime. So h prime is going to be the derivative of g, which would be g prime. That's the given graph. Minus, when I derive the 1/2 x squared, I just get an x. So this is my derivative. Now, the first thing to notice about these kinds of critical points, right? I could have a critical point when h prime is 0, which would be when g prime of x minus x is 0, which is essentially when g prime of x equals x. And we'll deal with that in a sec. Or I could have critical points when h prime of x does not exist. But that's not an issue here. The reason it's not an issue here is because g prime exists on this entire window. Now, the derivative of g prime may not because of these pointy things. The derivative of this does not exist. However, we're not looking at this thing's derivative. We're looking at g prime, and g prime is what we have here, and it exists. So that's not an issue. And the other issue would be included endpoints but in this case, in part C, there aren't any, right? So there are none, because although the endpoints are -7 and 5, they gave us the window from -7 to 5 exclusive, right? So there aren't any. So essentially what I'm looking at is really just the spots where G prime equals X. So this is what I need to find. So we have this graph of G prime. So this graph, right, this is the original graph that I was given. And if I want to graph y equals x, if I want to graph what y equals x looks like, it's the point 0, 0, 1, 1, 2, 2, 3, 3. It's this line, right? I'm not great at drawing it, but you get the gist. Well, it seems to me that there are exactly 2 places that the original curve hits that line. Right here, which is the slightly harder one, and right here, which was given to me as 3, 3 already, so that's great. So there are 2 points, right? Point number 1 is right here, and point number 2 is quite obviously 3, 3. It's when x is 3, right? So the question mark is, how do we find point number 1? So in order to find point number 1, there's a couple different ways you can go here. I really don't care which one you pick. The AP chose to recognize that you should be able to know the equation of a semicircle. So the AP said, hey, you should know that a semicircle with radius of 2, right, centered at the origin, has equation y equals the square root of 4 minus x squared. And that's great. If you want to know that, that's wonderful. I think it is a thing worth knowing that this is the equation of a semicircle of radius r, so this would be r squared, radius 2, right, centered at the origin. That's great. If you wanted the other semicircle that was down here instead of being a positive in front of the square root, it would have been a negative. I think it's great that you know that. If you don't know that, there's another way to think about this. You know this is the line where y and x are the same, right? So if I look at this like it's a little right triangle, right? If I bring it over here for a sec, you're looking at a right triangle where the radius is definitely a 2 because it's a semicircle, and both of these sides are x's. You can use Pythagorean theorem to find the missing side, or you can treat it as a 45, 45, 90 triangle. I don't care how you get what this x value is, but you're going to need to figure out this x value. So I'm going to do that work right here and show you. So for point number 1, right, so that point number 1, I probably would have done this. I probably would have said, oh, x squared plus x squared equals 2 squared, 2x squared is a 4, x squared is a 2, x is either a plus or minus root 2, but I'm in quadrant 1, right? I'm very clearly in the quadrant where both x and y are positive, so x must be a root 2 in this situation. So I get that x is a root 2. Now that's one way to do it. The other way to do it is to take this equation and say that since you know y and x are the same, you could replace this guy with an x and then solve, and you would end up with the exact same equation that I ended up with here. I don't care how you get there, you just have to get that point. So now, I now have these 2 points. I now need to classify them as a max or min. So I did the first thing. What are the critical points? These are the only 2. Now classify them as max, min, or neither. So the thing is that the graph I was given is already a sign chart. So notice that if g prime of x is bigger than x, then h prime is positive, right? Like if g prime is the bigger number, then when you subtract x, you get a positive. And if g prime of x is smaller than x, then h prime would come out negative, right? So essentially, if the black curve is on top of the blue curve, then I must have a positive value. So if you look at this sign chart I could make, right, if I just call this my h prime, right, my critical points are the not included -7, the square root of 2, the 3, and the not included 5, right? Here's the thing I know about h prime. On this window, the black curve, g prime, is physically higher than y equals x. So since the black curve is a larger number than the blue curve, black curve minus blue curve must net positive. In this window, between root 2 and 3, the blue curve is on top of the black curve. So black curve minus blue curve must come out negative because, again, you're doing the smaller value minus the larger value. That's going to net negative. And then on this window again, from 3 onward, what you'll see is that the blue curve is on top of the black curve. So again, just like it was here, we should get something that comes out negative, right? So although my h prime was 0 here and here, what's going to happen is my h is going up, down, level, down. So I have a max at root 2, and I have neither because this is what we call a saddle, right? That's a saddle. At x equals 3. So there, they say explain your reasoning, right? There's a number of different ways to do it. I would argue that the easiest option is to say something akin to this, right? Is to say, so if I go to explain this, because they did say explain, not justify, which is sort of relevant, right? So when asked to explain, my answer to part D, right? I would probably say something akin to x equals root 2 is a max because, this is my window, because on the window from -7, we can actually go ahead and put a bracket, from -7 to root 2, h prime of x is greater than 0, and on the window from root 2 to, well, essentially we'll just say root 2 to 3 for now, h prime of x is less than 0, right? That's enough of an explanation. I could have also said it as h is increasing and h is decreasing, right? And then x of 3 is a saddle, right? So, and I would clarify, I would go out of my way to point out that that means neither, right? Because h prime of x is less than 0 on both sides of x equals 3, essentially meaning from root 2 to 3 and from 3 to the unincluded or the now included 5, right? So again, when you're asked to explain, you're explaining essentially what you did visually with a picture, but in words, they want to see that analysis. Okay.